The Sun. It lights our world, heats our planet, controls our weather. The Sun's gravity even keeps Earth from drifting off into the icy cold depths of space. Yet one day the most important star humanity has ever known will turn on our planet and vaporize our very home. Welcome to Space School. The sun has been worshipped as a god throughout much of recorded history. The Aztecs in Mexico, the builders of Stonehenge in England, the ancient Egyptians, all saw the sun as a deity. The ancient Greeks called the sun god Helios. The Egyptians named him Ra. Even after Copernicus in the 16th century proved the sun was the center of the solar system, debate still raged over just how a single body could give off so much heat and light. In the end, it took the genius of Albert Einstein and his famous equation E=mc² to decipher just how the sun worked. The sun's warmth and light, he realized, came from converting matter directly into energy through atomic reactions. The sun forms the center of our solar system and contains more than 99% of its mass. Our home star's diameter is 864,900 miles, 109 times greater than that of the Earth. Because of its immense size, the sun has a powerful gravitational force, powerful enough to hold 8 planets, more than 200 moons, and countless other celestial bodies in orbit. One of those planets, Greek for wanderers, is our own home, planet Earth, 92 million miles from the sun. The star we orbit, the star that forms the center of our solar system, is more than 4.5 billion years old. It has no solid surface. Rather, it is comprised of gases, mainly hydrogen, helium, oxygen, and carbon. Gravity binds these gases together, pressing them towards the center, giving the sun its spherical shape. That gravity also creates intense pressure and huge amounts of friction. Friction that causes the sun's hydrogen to be converted into helium, meaning our sun is a supersized atomic reactor. The process is called nuclear fusion. It occurs when 2 atomic nuclei are forced together, forming a single new element, releasing huge amounts of excess energy. Every second of every day, our sun produces as much energy as 1 trillion megaton bombs. Every second, 700 million tons of hydrogen are converted to helium, releasing 5 million tons of energy. The sun's surface is called the photosphere. Temperatures here can exceed 9,900 degrees Fahrenheit. At the sun's core, temperatures reach a staggering 127 million degrees, and the energy created at the core takes nearly 100,000 years to reach the surface. Once it gets there, this energy escapes as radiation, and just 8 minutes later reaches the Earth in the form of light. Due to the intense heat, most of the sun exists in a plasmatic state, a state beyond a gas where atoms have become ionized, losing some of their electrons and positive ions. Some of that plasma escapes the sun's gravity as solar wind, and when those charged particles reach the Earth's atmosphere, they react with our planet's magnetic field. We see this reaction as a glow in the night sky, the aurora borealis, or northern lights. Some scientists believe that solar wind could replace rocket fuel to power a spaceship. 5.5 billion years from now, the sun will begin to go out. Having consumed most of its hydrogen fuel, the core will contract and heat up, causing the outer layers to expand. Our sun will become a red giant, growing so large that it will actually reach the current orbit of the Earth. After that, the sun's outer layer will burst, releasing thick pockets of gas into space, creating a planetary nebula, a glowing shell of gas and plasma. Illuminating that shell will be a white dwarf, a very dense and bright star roughly the size of Earth. Eventually, all of its energy will be expelled, leaving behind a black dwarf, a dead star. As for the future of Earth, even if it escapes into a more distant orbit, temperatures here will rise so high that water and life as we know it will cease to exist. Fortunately, this entire process will take billions of years, and hopefully by that time, humans will have colonized other planets in other solar systems. No black dwarfs exist. The universe is too young for a single star to have completed a full life cycle. The sun, for us, is without a doubt the most important star in the universe, and studying it is key, both to our understanding of the cosmos and to the future of our species. This is Space School signing off. Class dismissed.